store description of itself. The self-describing data is called metadata, which is the data about the data. And we're going to get into that. So, two very important things. It is self-describing, it's integrated, it is self-describing because it stores information about itself, and we'll see it how. And it is self-describing data because the self-describing data is called metadata, which is data about itself. Okay, so here is an example. If you look at the table student, the student has 4 columns, and the 4 columns are student number, last name, first name, and email address. And we're saying that the student column, the student table describes itself. It says that the student number is of data type integer and has a length of 4. Last name is text and a length of 25. First name is text and a length of 25. Email address is text and the length is 100. So when we say student, we say the student table is self-describing. That means student table, we are describing student table to contain 4 columns, and the columns are student number, last name, first name, email address. And we are also saying that the student number is integer, last name is text, first name is text, email address is text, and we are saying how big those individual items are. So basically it says is those are the self-describing feature of the table, and those are the metadata. That basically is telling me that we can have a student number. If we have a student number in our table, there must be 4 character. It should be 4-digit long, and it's an integer. If we have a last name, it can be up to a maximum of 25, and we can only have text in it. If it is the first name, we can have 25 character, and it can only have 25 character and first name. Email address, we're also saying that this is all characters, and it can be up to 100 character long. Similarly, if you go look at the class, there are 4 columns for class, and those columns are class number, name, term, and section. For grade, we have 3 columns: student number, class number, and grade. So, as you see, this is called metadata, and it's important that we have metadata about that the tables store data about, like here you say, the database is a self-describing collection of integrated tables, and the table contains information about, contains metadata which describes what the table can contain. So tables of user data, metadata, index, stored procedures, I think we're going to talk a lot about it. We probably will not get into this access thing at all. We're not going to, in this class, we're not going to talk about it. But here's a good slide on enterprise class database systems. Again, these are the users. Let's say you are working in a corporations, and there is you are the end user, and this is applications running over corporate network, e-commerce applications on web server, web portals with reporting, and so these are all applications that a user in a corporation is using. So what are those applications? So let's say this is the application running on corporate network. This is your HR system, the human resources system, where you go in and sign up for benefits, look at your healthcare staff, look at your payroll staff. Let's say you have your company is has a e-commerce site that they're selling something. That is the primary application that your company is selling. Web portals, say your company has an intranet that employees come in and is primarily used as a communication mechanism between employee and the employer. All these applications that we are seeing here basically talks to a SQL database, and the way the communication happens between the enterprise applications to the DBMS, to the database, and the common language they use is SQL. So most applications that we have today use SQL to talk to, whether you are using SQL Server, Oracle, MySQL, whatever may be the database of your choice. For any enterprise application to function properly, they must communicate to a database, and those are the major databases: SQL Server, Oracle, and MySQL, which are the primary databases that are being used currently. And when you talk to the database, most software developers, whether they're using C#, VB.NET, Python, Ruby.Rails, or any other programming language, PHP, all of them use SQL to get to a system. So this should be like you should be very familiar with this kind of diagram to say where you are. In this class, we're going to do 2008 or 2012. I will not really go with any other database. So whatever you get from whatever the department is providing. DBMS power versus ease of use. Probably a lot of you have used Microsoft Access, and I think this is a great chart. Access is simpler to use. MySQL is probably a little bit more complex. SQL Server and DB2, Oracle, DB2 are more complex applications, and usually those are more powerful servers also. So the easier it is to use, the less powerful they are, the more difficult it is to use, the more powerful those applications are. So most large applications either use SQL Server, Oracle, or DB2. DB2 is a product from IBM, and Oracle is from Oracle Corp, and SQL Server is from Microsoft. So all these applications are again, for most corporations. You see, for any enterprise class applications, it's either MySQL, SQL Server, Oracle, or DB2. Access is used in silos for small applications, not really for enterprise applications. Okay, so this book, the database design, I think there are, I really don't like the way the book talks about this, but let's see. I don't think I'm going to Okay, I think we'll go a little bit into the history. I think that's more interesting. Prior to 1970s, before 1970, there used to be no database. In early 70s and 1980, there was Adabas, there were few, but really the emergence of relational database came in 1982, 78 to 1985, DB2, Oracle, 1982 to 1992, DBS, Paradox, Access, 1985 to 2000, Oracle. Web databases as Apache, PHP, ASP.NET, those 95 to present, open source, I think MySQL, Postgres. Again, for this class, we'll be focusing on, this is kind of nice to know, but basically from late 1970s, 80s, the databases have really played a big role in software development. And primarily, this class will be focusing on MySQL, SQL Server, and Oracle, with SQL Server being the dominant database in the market today. We're going to do our project, and for all practical hands-on stuff, we'll be using SQL Server. The dominant database model and the relational are based on it. So all databases that we are going to talk in this class are relational databases. It was created by E.F. Scott in 1970. It's based upon something called a relational algebra. We're going to get to that in detail in later classes, and how to do normalization and stuff like that. But so that's pretty much just the overview of where we are. And okay, let's see. We'll go to the next slide. Let's see. Let it convert, it will be faster rather than. If anybody has any question, just go ahead and type it in. I am going to send the slides. I think somehow in this conversion that Blackboard does, that file probably is corrupted. So I'm going to repost it on Desire to Learn, and I'll try to send it again, and I'll make sure that I am able to open it from the email that I send you guys. So I will, maybe I can do it now as we're waiting. Okay. So I think this chapter is probably one of the most important things we'll be talking in this class. That is introduction to standard query language. There are lots and lots of slides on this, so let's get away with it. So the standard query language is the language that programmers and software developers and database administrators and database analysts, report writers, a lot of people use to get data in and out of the database. So once we have the database management system, which is usually developed by the vendor, like SQL Server by Microsoft, or Oracle by Oracle Corp, or by MySQL, which is now also owned by Oracle. The job of the database developer, or software developer, or report writer, or query writer is to be able to insert data and get data out of the database. So the objective of this chapter is to understand the use of extracted data sets in a business intelligence system, to understand the use of ad hoc queries in a business BI system, to understand the history and significance of structured query language, to understand the SQL select from here. Okay. So in short, the objective of this is to teach you how to write SQL statements and store and retrieve data from a database. Okay. Okay, from a business systems and business intelligence is nothing but retrieving information about the data that you have stored in a database. So that's basically it is. So, ad hoc queries. This is, as a user of the system, questions that can be answered using database data. How many customers are in Portland, Oregon bought our green baseball cap? That's the question. Or how is our revenue in the northern division is doing to the southern division? How is our revenue compared this month versus last month? How is our revenue compared this year versus last year? How many employees we have? How many employees? What is the turnover of the employees that we have in a particular year? Those are the kind of questions that you ask. That I'm not going to go to the data warehouse. Okay, so the SQL was developed by IBM Corporation in 1970s. SQL was endorsed by the U.S. National Standard by American National Standard Institute. So SQL is basically the standard that all database vendors, as I said earlier, have agreed to use as a language so that people who are manipulating the database do not get into learning different things to get the data out. So this is the standard. The U.S. National Standard adopted it, and we are learning something that will help us learning the particular standard. Couple of things. SQL is not a full-featured programming language, so it has constraints. So in order to, it is good for ad hoc information, little bit of information, subset of information, but it is not really good for implementing full-fledged application. So you never see an application like Expedia or Priceline or Google or anything. Any application, Google search, which is written in SQL. SQL, it is not a full-fledged application, but it is a very important add-on to a programming language like C, C# or Java. So if you have an application, the application must embed SQL in the programming language to retrieve data from the database. SQL is a data sublanguage for creating and processing database data and metadata. SQL, it could be an enterprise class DBMS product. It is everywhere. You cannot find a database. Well, it's hard to find a database which does not support SQL. SQL programming is a critical skill. Without knowing SQL, and no database developer or software developer or report writer will be able to produce anything. So SQL is a key component of any, if you want any of those roles, end user, a database end user, or a SQL developer, or a report writer, or a software engineer, or a business analyst, you need SQL skills. SQL statements can be divided into three categories: data manipulation, data definition language, data manipulation language, and SQL persistent modules. So the data definition language is used for creating tables, relationships, and other chapters, and other structures. So you'll see that SQL consists of three independent languages. The data definition language is the language, and we'll cover that in chapter 7, is how to create tables itself. Data manipulation language is is used for queries and data modification covered in this chapter. So this is what we are first going to go to the DML. That's basically data manipulation language. How do you run queries? How do you modify data? We'll go into the data definition language in chapter 7, where we are going to talk about that how you do data definition, how do you create databases. Also, we're going to talk about SQL persistent stored modules. Those are called stored procedures, and we'll be in later chapter, I think chapter 10, we'll be talking about stored procedures, and we'll be figuring out how stored procedures help in programming. Okay, so we'll be talking about this Cape Cod Outdoor Sports. Cape Cod Outdoor Sports is a fictitious company based on an actual outdoor retail equipment vendor. Cape Cod Outdoor Sports has 15 retail stores in United States and Canada, has an online internet store, has a postal mail department. All retail sales are recorded in an Oracle database. So we're going to take this example, and we're going to get into details of how to run data manipulation language. So here is an example. Cape Cod is sports, has 15 retail stores, has an online internet store, and also has a mail order department. All retail sales are recorded in an Oracle database. So this is how it will look like. Store 1, they have a point of sales, like I was talking to you about, that you go to a grocery store, you see a point of sales. Similarly here, all the 15 stores have a point of sale application. When you buy something from Cape Cod retail outlet, you go through a point of sale system, which talks to an Oracle database at the back end. And here is the web front end to an internet store. So it might be something like Amazon or Overstock or Walmart or whatever. So this is the web front end. And they also talk to the same database because they're selling the same stuff. And then there's a mail order system, which is maybe a client server based system, which is operated by some users, and they all access this Oracle database. So the Oracle database is located centrally somewhere, from where these people are able to, all these 15 stores are able to go get in there and use the different applications. So it doesn't matter what language your application is written, whether it is a point of sale application, whether it is a web front end, whether it's a mail order application, all these applications know how to connect to this Oracle database, retrieve data, modify data, insert data into the Oracle database, and able to do this. And this is the retail store sales data structure, and this is called a data warehouse. Then the data warehouses are usually done to get business intelligence on the corporation. So instead of, if you look at this database, this is the database, and all these people are using this particular database. And maybe at the same time, the CEO wants to know how is your sales happening, what is your sales for this particular month, store 1 versus store 15, or all the stores that he or she has. And it is not very practical, or it is not efficient to run those kind of aggregating functions on a database, on a retail system, or on a live system. If we run business intelligence kind of reports on this system, it tends to get slower, because these people are standing in front of a customer and they're trying to fulfill an order, and you don't want to slow them down. So for business decision making, usually we extract aggregate data from transactional data, the data of selling one widget from CAD code is a transactional data. Getting a summary of how many widgets we sell is a aggregated data warehouse data. So for those kind of information which helps the senior management, really the clerk who is selling something with a point of sale application in a particular store really doesn't care about aggregated information. The chief executive sitting in his or her office really doesn't care about individual transactions. So this is the way we get aggregate information from individual from the database into another database so that we can run those kind of statistics there. The CAD code marketing reporting needs an analysis of in-store sales. The entire database is not needed for this, only extraction of retail sales data. The data is extracted by the IS department from the operational database into a separate offline database for use by the marketing department. So this is exactly what I said. I was talking about the CEO, but here they're giving an example of the marketing department. But the idea is the same idea, that the entire database is not needed, only extraction of retail sales data is needed, and there are three tables are used: detail order, order item, and SKU data. The extracted data is converted as necessary into different databases, DBMS, Microsoft Server, into different columns. Order name becomes order month and order year. Okay, so basically we're saying that we're going to get some data. So here is the extracted detailed data format. Retail order, we're getting retail order, order number, order store numbers, store zip, order month, order year, order total. The order item table has order numbers, SKU, quantity, price, and extended price. SKU data has SKU description, department, and buyer. So we will come to this example. Keep that in mind, because this is the basic thing that we will be going back to again and again as we go through this class, for at least for this chapter. But that is, keep that in mind. So the first thing we talk about SQL is select. So in order to get anything out of a database, the first thing of retrieving data from the database, the first thing we learn is a select statement. So you will be throughout this class you will be asked to, on all your quizzes, your midterm, final, there will be lots and lots of SQL statements that you will be asked to write. So spend a lot of time learning SQL, and we'll go through it as much as we can in this class. But you have to spend a lot of time at home besides this class to learn this and master it, because there will be lots and lots of questions on SQL. So the first statement we learned is select. So it says the syntax is select column name or names from table name or names where a particular condition meets. All select statements end with a semicolon. So here is an example. Select department buyer from SKU data. So let's go back to the, I think this will be a little hard. So if you see here is the table. The table has two columns, department and buyer. If you see department and buyer, and we're writing a SQL statement which says select department, comma, buyer from SKU data. SKU data is the name of the table. So you are saying the syntax goes like this. So if you have a table called SKU data and you want to find two columns there, department and buyer, then you say select department, comma, buyer from the table school data, followed by a semicolon. It's very picky. If you don't put a semicolon, this thing will not work. And if you are it is in a test, then you lose points because semicolon is important. Without that, the SQL doesn't know that the select statement has ended. That is the way for for us to tell that okay. Also, I see a lot of people, if you are in and out, just note that the system records every how many minutes you are here, how many times you dropped, how many times you came back. So that will certainly impact the overall grade. So I will encourage all of you to be in the class, not to be in out or not focus on the class, because in a real classroom I can really figure out who is focusing and who is not. And here I have no way to know unless I go through all this data, and I will. So just wanted to remind that. Specifying column order. If you want the order in which the column is result is displayed, if you do buyer in department, then buyer will be displayed first, department later. If you choose department comma buyer, then department will be listed first and buyer later. So okay, so that's select. So you must know how to write select. So if you have to do select, you must select the name of the columns that you are getting, then the word from, and name of the table from which you are getting those columns, followed by a semicolon. Okay. Distinct. Distinct is a keyword that we use. So distinct basically means that you are getting, if your goal is to find out a distinct buyer and department, then buyer will only be if there are one buyer, you can only list, like let's go back and see. Here you see it listed Pete Hansen Water Sports, Pete Hansen Water Sports, Nancy Meyer Water Sports, Nancy Meyer Water Sports, Cindy Lou Camping, Jerry Martin Camping. If you do the distinct, it will only list them once. But Cindy is doing camping, Jerry Martin is doing climbing, Nancy Myers is doing water sports, and Peter Hansen is doing okay. Selecting all columns. So when you say select star from school data, that brings all columns associated with school data. School data, like we showed last time. Let's see that. School data has school description, department, and buyer. All the 4 columns. So there are 2 ways. If you want all columns, you can say select school, comma, school description, comma, department, comma, buyer from school data, or you can say select star. Both of them do the same thing. If you do the select star, then okay. Let me know if you don't get it. Specific rows from one table. select star from school data where department equal to water sports. So this is where you're saying, I'm not really interested in everything that school data has. I am interested in getting, selecting only where department equal to water sports. So select star from school data where department equal to water sports. So this is the important part, where department equal to single quote, water sports, single quote, semicolon. Equal, there is a space, single quote. So anytime you want to equal something to something, you should must put it in single quote. Nothing other than single quote. No double quotes, nothing but single quote. So select. If you want the name of a column, you can say what column from school data where department equal to water sports. So this is to get specific rows, not every row. Specific columns and rows from one table. So if you want specific columns, then you say select the name of the column, school description, and buyer from school data where department equal to climbing. You see how it's slowly getting more and more complicated. Initially we say, just give me two columns. Then we say, okay, we want just all columns. Then we say we will add a condition which say department equal to climbing. Here we say, give me two columns from school data where department equals to climbing. Again, remember, anytime you are doing equal to, it must be single quote, climbing, and the name of thing that you are going to match, another single quote, semicolon. So that's what we're going to do. If you're not following it, let me know, because we are going to cover SQL in two classes, this class and next class. And SQL is, as I said, is a very important tool for software engineering, database report writers, and honestly, two classes is too fast. Even on a regular semester where it takes 2 weeks, here it will take a week. And I can emphasize enough that you must go in and start writing queries starting tomorrow in SQL Server to get a feel for this. I'm not going to go through Access. I'm not going to talk about MySQL and all that. So, but we're going to go through these concepts. We're going to go through several examples next class. But SQL is just huge. There is just too much stuff. You can pretty much teach it for a month or so, at least 4 to 5 classes. But the way this class is designed, there's not enough time to spend. Easily we can spend 4 lectures on SQL. So you really have to substitute therefore yourself to get there. Okay, so the other thing we're going to talk about today is sorting the results, which is, now we said we did a select, we did a select, and we did a we did a select, we did a condition, how we're selecting them. Then we did we did a select star. We did a selected number of columns. We did all of those things. So in this particular example, we are going to do the select star from order item where order by, order number, price. So here we are, if you see, if we got the all the columns, order number, school, quantity, price, extended price, from order item. Then we order by, order number, price. So the first order is, first we sort them by order number, so that it starts with 1000, and then the next thing we sort, then we sort it by price. So 300 to 130. So we sort them. So order by sorts them in that particular order. Sort order ascending, descending. So when you are sorting, you can do a ascending order or you can do a descending order. In this particular example, we are doing. You can mention select star from order item, order by price, descending, order number, ascending. So you can mention which one. So if the first, it will group by, it will order by price descending. So if you see order number ascending, price descending. So you can mention, DESC means price is descending, order number ascending, ASC means order number. The default sort order is ascending, doesn't have to be specified. So you can mention whether it is descending or ascending based upon the word DESC or ASC after the column number, column name. Select star from school data where department equal to water sports and buyer equal to Nancy Myers. So this is where you can say where clause option, where, I think we already did where, but you can have multiple conditions also. Instead of just having one condition, you will have multiple conditions. You can have department equal to water sports and buyer equal to Nancy Meyer. And so the logic here, basically what we're just here, where we're showing is, show me everything where buyer is Nancy Meyer and department is water sports. And you can see that this is the result we are getting. Similarly, as like and, we can have or. So select star from school data where department equal to camping or department equal to climbing. So it will, in case of and, it will show where both the conditions are met. So water sports, you can see water sports and Nancy Meyer. Buyer is the department is water sports and buyer is Nancy Meyer. It shows all the schools for water sports department, for which the buyer is Nancy Meyer. Here we're saying, show me everything where the department is climbing or department is camping. And you get both. When you say or, you get climbing department and you get camping department. So we are getting camping and climbing. If you made it and, you probably would have not got anything because there is nowhere department is camping and department is climbing. Department is either one of the two. So they are mutually exclusive, and you would have got anything out of it. But or means I am looking for everything in camping or climbing department. Okay, so next thing, which is another important concept, there is the where clause option in. Select star from school data where buyer in. So we're trying to find everything in school data table where buyer in Nancy Myers, Cindy Lowe, and Jerry Morton. Where what buyer in exactly means? It basically means you could have written that in another form where you could have said where buyer equals Nancy Meyer or buyer equals Cindy Lou or buyer equals Jerry Martin. That this is the equivalent of that. So this is basically saying buyer in, that basically means buyer is either Nancy Myers or Cindy Lou or Jerry Martin. If buyer is any of the three, then it selects show me everything for that school data item. So in is a concept to use when you have multiple ORs. So if you have or, you can write or you can do in and reduce the number of lines of or that you have to write. So in is a substitute for multiple ORs. It's a short form. It can do it much quicker. Then there is also the concept of not in. So when you say or, then you could, here we're saying select star from school data where buyer not in. Buyer not in means buyer is not Nancy Myers, buyer is not Cindy Lou, or buyer is not Jerry Martin. Okay, of course, that means Pete Hansen is the only buyer. But the thing that we are discussing is saying that SQL is powerful enough, it can say, give me the buyer who is one of these three, or give me the buyer who is none of these three. And those are the important concepts okay, this is the last thing we'll be talking about. I know some of you, I will try to record from next class because I am, and I will try to send the slide again probably right now. Let me do that as we are speaking so that let me go to Desire to Learn, upload the latest copy and see if you guys can do it. Give me 1 second. Let me go to Desire to Learn. And I will put up the new slide right now and I'll check with you guys to make sure you can see it. I don't know what happened to that slide and why it was giving all this problem, but we'll see. Okay. All right. No, not this one. Slide 1. Okay. Hello. Edit file. Browse. Okay, let's go. Can you all check if you are able to get chapter one slides from project to one. I put the new copy, so you should be able to get it. Let me see. Okay, so okay, so I think that's how much we're going to go. We have less students today, so I don't want to go too much. We're going to go to chapter 2. You have now the slides for chapter 1. If you have not signed your group, please send it today or by the latest by tomorrow. Your group and we'll finish chapter 2 next time, and we'll go through all the course and the exercises and at the back of chapter 2. Usually we'll go through several of them to give you a very good feel for how to write SQL and all that. In the meantime, spend some time with SQL, getting into SQL Server, trying to get installed, get it in the lab, start writing SQLs, because as I said, this is the class today, and next class is the class that will go we'll go with SQL. If you still are having a problem with joining the class, call that 888 number, and they should be able to. I even called them, and they were very helpful. Call them. If you have any questions in the meantime, email it to me, and I will check email every day, and I'll get back to you pretty quickly. And if you have any questions, let me know. Otherwise, we will see you on Tuesday at 7:40.
Are we able to use the mic?
I think we said the group is about 4. I don't think there's a quiz next class. I think next class probably there should not be a quiz. I can look at the cell levels right now. Let me see. I don't think this level says there is a class quiz next class. Let's see. Unless I'm wrong. I thought it's the 4th class. It's on June 24. There is no quiz tomorrow. C syllabus, there is no quiz next class. Okay, good night, everybody. I think I will. Is there a need for this? I can keep this session open for next 20 minutes if there is a need for it. If you need me to keep it open, let me know next minute or so. Otherwise, I'll close it.